Hello everybody and welcome back to another TerrNav tutorial. Today we're going to be talking about running fixes. There's two different types of running fixes you can encounter. We're going to do problems with both of them. So first thing I want to start with trackline is my DRs. And you want to be careful because right here we've noticed that 11:36 is our starting time. So we don't want to do a DR from there. We want to figure out where the nearest half hour is, so that would be 12 o'clock. The way we're going to do that is we're going to get our calculator. 60 minus 36 is 24 minutes divided by 60 is that many hours, times our speed, which is 14 knots, is 5.6 miles. And 5.6 miles from here, that's when we're going to hit 12 o'clock. So that's going to be our first DR. So we're going to go over here, 5.6. All right, there's our 5.6. So right there, we're going to go to here. And then that is going to be our 1200 DR. Now we have to do them every half hour, and we know that our speed is 14 knots, so every half hour that's going to be 7 nautical miles, right? 7 nautical miles is right here. So from there, that's going to be our 1230 DR, and then we got to figure out when we're going to hit waypoint 1. And so we just got to figure out what that distance is and then divide it by our speed, right? 1, 2, 3, 4 points. 1, 2, 3, 4, 5, 6. 4.6. So it's 4.6 nautical miles divided by our speed of 14 knots. So that decimal hours times 60 is about 20 minutes. So 20 minutes from 12:30 is going to put us at 12:50. So that's our ETA. We know that northern point light, which is over here, is bearing 110 degrees true. So we're going to have a line of position here. So we're going to line this up over here, figure out where 110 degrees is. So line that up right like that. And then we're going to slide that ankle down to the northern point light. And then we know that we're going to be somewhere on this line of position. And we're going to label it with our time, which is 12:12, because it says it right here. And then we're going to label it with our bearing, which is 110 degrees true. So now we know that the same lighthouse bears 165 degrees true later. So we know that later it's going to be 165 degrees true. So we're going to figure out what 165 degrees is. So 160, 165 is right here. And we're going to label that the same way. So now our task is to do a running fix between these 2 points. But before we do that, 6 rules of DR. Anytime you have a line of position, you need some sort of DR. So we know that from 12 to 12:12, that's 12 minutes. 12 minutes divided by 60 times our speed of 14 is 2.8 nautical miles. So we're going to have a DR 2.8 nautical miles later. And then we need a 12:36 DR as well. Again, 6 minutes divided by 60 minutes in an hour times our speed of 14 is 1.4. So this, or 12. And always make sure that you're writing these at an angle to the track line. 12:36 DR. Okay, so that's all of our DRs done. DR check, check. So now the complicated part. I have to figure out from 12:12 to 12:36 how far I've gone along this track line, assuming 14 knot speed. And then I'm going to advance this line up to that point on the track line, and then where these 2 points intersect is going to be where my running fix is. So let's do some math. 36 minus 12, because we went from 12:12 to 12:36, is 24 minutes divided by 60, 0.4 times our speed of 14 is 5.6 nautical miles. So I know that from somewhere on this line here, I have to move up 5.6 nautical miles. So from there, I'm going to move it up to that point right there on my track line. So now what we do, we align this on that line of position, and then we advance it until it strikes that point there. And then we just draw that in there. And then we have to tell whoever's on watch that this is a thing that was moved. This wasn't a new line of position. So we're going to label it 1212 to 1236, bearing 110.0 degrees true. And then where these two lines intersect, those are both visual bearing fixes. So we've got a circle, and we're going to label that 1236 R fix. So now I have to figure out what my course made good and speed made good were between my fix here and my fix here. So I'm going to do that. Course made good's fairly easy. We're just going to take our triangle. We're going to run from our initial fix to our running fix, and we're just going to slide it over to meridian to figure out what we've got. That's looking like about 80.5. So, of course, 0.5 degrees true. You always want to bring it all the way up. I'm just being lazy for the purposes of this video. All right, so our speed made good. That's going to involve figuring out what the distance is between these. So, I'm going to take my nice dividers here, like that, and then we're just going to run it down from here up to wherever it hits. And so 13.5 nautical miles. 30.5 nautical miles, and we did that in 1 hour. So 13.5 nautical miles in 1 hour is, by definition, 13.5 knots. So now the tricky part is we got to figure out what our set is, and that's the direction that we were being pushed off of our track line. And so the way we're going to do that is by measuring the angle between your 1236 DR, which is where you hoped you were going to be, and your 1236 R fix, which is where you are. So take that angle. Now with these chartlets, it's a little hard. We're gonna have to end up bringing this up and then over just to hit the meridian properly. And current and set is measured in the direction it's going to, and so I'm getting set 130.5 degrees this way. So now our drift. Our drift is going to be the distance off of our track line and the time. So we went from the track line to there, which is 0.5 nautical miles, and we did that in 1 hour, so 0.5 knots. So our course of advance is what we now need to steer in order to get from our 1236 R fix to our waypoint. So same deal, measure it. It's looking like, yeah, like 76.9. So 0.76.9 degrees true. So now I have to figure out my course to steer. And so that's taking into account what I'm being set down by the current or the wind or whatever's pushing me off my track line. So the way I'm going to account for that is I know what my course of advance is, and I know what my course made good was. So the difference between those is going to be 80.5 minus 76.9 is 3.6 degrees. So that means that I'm being set off that many degrees, and so for my course of advance, in order to compensate for that, I have to steer higher up an extra 3.6 degrees. So we're going to do 76.9 minus 3.6, which is 0.73 degrees true. And then ETA, that's pretty simple. Just got to figure out what the distance is, divided by our speed of advance, because we're assuming for purposes of keeping the math easy that we're still doing our speed of advance. So we're going to 3.7 nautical miles. So 3.7 nautical miles divided by 14 times 60 is 16 minutes. So from 1236 plus 16 is 1252. And that's that. Oh, and then we also have to do the latitude longitude of our fix. It's looking like 0.73 degrees, 7.8 minutes west. And then we got to figure out what our latitude is. So do the same thing here. That's looking like about 4101.5. Okay, that's how you do one of these problems. Okay, so the second type of running fix problem you can have is one with radar ranges. And so I've already put our DRs down and our ETA. We went over that last time. So let's just get right into it. We know that Western Point Light is 4.6 nautical miles. First time we sight it. So get our 4.6. So we know that we're going to be somewhere on this arc here. 1615, and it's 4.6 nautical miles. And then at 1648 we sight Northern Point Light at 5.2 nautical miles. So we know then that we're somewhere along that arc there. And that was at 1648. And remember, always have to have a DR when we have any sort of line of position. So got to figure out 1600 to 1615 is 15 minutes divided by 60 times our speed of 14 is 3.5 nautical miles. So it means we're pretty close. 1615. And then I need a 1648 DR, which from 1630 is 18 minutes, so 18 divided by 60 times our speed of 14 knots is 4.2 nautical miles. All right, there's our 1648. So we got all of our DRs. Check, check. So now the hard part is we have to advance this from here to here. Now we can't advance an arc. What we have to do is we actually have to advance the light itself. So we're going to have a line that's going to follow our track line. We're going to bring it down to the light, and we're going to extend it some distance this way. So now what I have to do is I have to figure out how far I went from 1615 to 1648. So 48 minus 15 divided by 60 times speed 14 knots. So on this line we went 7.7 nautical miles. So I know that that's my new point, and from there that's where my new 4.6 nautical mile arc is going to be from. So 4.6, draw this arc in, and we have to say that it's a running fix. It's been advanced, so 1615 to 1648, 4.6 nautical miles. And we know that these were two electronic radar ranges, so our symbol for that is a triangle, and we're going to label it our 1648 R fix. So now we have to do all the same stuff we did earlier, but I'm not going to get into that because I just explained it in the last one. If you want to try it for practice, you're welcome to, but I just explained it in the last one, and I don't want this video to be like 2 hours long. So that's how you do running fixes. If you have any questions, maybe I messed something up in the video that I didn't notice, leave them in the comments. Other than that, I'll see you guys in the next one. Bye.